In this course, we will cover best practices for securing your React applications. The intent is to equip you with the knowledge necessary to harden your UI code effectively, aiming to prevent attacks against your React components. This involves understanding how different vulnerabilities can be exploited and what strategies can be implemented to safeguard your code. This course is designed for developers who are looking to deepen their understanding of React security to ensure the safety of both users and developers alike. By the end of this course, you'll have a solid grasp of how to protect your React applications from common threats and potential vulnerabilities. Let's dive into the importance of securing your React applications, starting with an overview of some common threats and best practices. Cross-site scripting, XSS, is a significant risk, allowing attackers to inject malicious scripts into your web pages. This can lead to unauthorized actions and data exposure. Safe dynamic HTML rendering is critical to prevent these attacks. Properly handling and sanitizing user input helps mitigate these vulnerabilities. Code injection vulnerabilities are another crucial area to focus on. They can lead to unauthorized code execution and compromise your application's integrity. Understanding and addressing these issues is vital for attaining certification and ensuring the security of your React applications. This not only protects your users' data, but also safeguards your development environment. Ensuring the prevention of cross-site scripting, XSS attacks, is crucial for maintaining the security of your React applications. One fundamental step in safeguarding your application is performing regular version checks to ensure that you are using the most up-to-date version of React. By doing this, you can take advantage of the latest security patches and improvements provided by the React development team. Staying current helps mitigate the risk of XSS vulnerabilities and keeps your application environment secure for both developers and users. In this slide, we introduce the Globomantics Bug Tracker Project. This project involves building a bug tracker application which will serve as an illustrative example for simulating common XSS attack vectors. Through this hand project, you'll gain a deeper understanding of how XSS attacks can be executed and mitigated in real-world applications. By working through this, you will become more adept at spotting potential vulnerabilities and implementing strategies to safeguard against such attacks. Stealing data with cross-site scripting, XSS, is a critical topic in understanding web security vulnerabilities. XSS attacks involve the execution of malicious scripts in a user's browser, allowing attackers to steal sensitive data or impersonate the victim. For example, an attacker can place script tags within form input fields, which when submitted and rendered can execute JavaScript code on the victim's browser. This can lead to unauthorized access to session tokens, cookies, or other confidential information. Understanding this form of attack is essential in securing web applications. In this slide, we're diving deeper into cross-site scripting, XSS, by discussing XSS sinks. These are points in the code where untrusted data can flow into the browser. Common sinks for XSS attacks include dangerouslySetInnerHTML and inline event handlers such as onClick and onChange. DangerouslySetInnerHTML allows developers to set HTML directly from JavaScript, which can be exploited if the input is not properly sanitized. Similarly, inline event handlers can execute malicious scripts if they include untrusted user inputs. Understanding these common XSS sinks is crucial for writing secure applications and protecting user data from malicious attacks. React provides automatic escaping to protect your applications from potential security vulnerabilities. Specifically, React automatically escapes values when they are embedded in JSX, which prevents execution of malicious scripts. For instance, when you embed user input in a React component using curly braces, such as div user input div, React ensures that the value is safely escaped. This default behavior helps mitigate risks associated with untrusted data being rendered directly into the DOM, making it an important feature for maintaining the security of your React applications. When rendering URLs that come from user input, it's crucial to ensure that these URLs are sanitized before they are embedded into your React components. This precaution helps to avoid the risk of embedding malicious links that could compromise the security of your application. Let's delve deeper into secure URL rendering by discussing a powerful tool, DOMPurify. DOMPurify is an exceptional library designed to sanitize user-provided content, ensuring that any potentially malicious code is purified before being rendered. In its basic usage, you can sanitize a string directly by passing it to dompurify.sanitize. For instance, dompurify.sanitize img sars equals x owner equals alert1 will clean the content, stripping out any harmful elements like the owneror attribute in this case. Additionally, DOMPurify offers various configurations, For example, you can pass a second parameter to configure its behavior. Using DOMPurify.sanitize, img sarsl x or alert1, safe for templates, true, enables a configuration that is particularly useful when you're working with templates. Incorporating DOMPurify into your workflow is a robust step towards ensuring that your application remains secure against potential XSS attacks by sanitizing any user-provided URLs effectively. In this course, we've explored the importance of handling dynamic content securely and the risks associated with unsanitized inner HTML. Here's a quick summary of our key takeaways. First, always avoid using unsanitized inner HTML, as this practice makes your application vulnerable to cross-site scripting, XSS attacks. Unsanitized input can easily be exploited to execute malicious scripts. Second, utilize libraries such as DOMPurify to sanitize any user-generated content. Libraries like DOMPurify are designed to clean and secure HTML and help mitigate the risks of injection attacks. Lastly, ensure that the React version you are using is up to date. React undergoes frequent updates to fix vulnerabilities and improve security, and keeping your version current can provide additional built-in safeguards. By following these guidelines, you can significantly enhance the security of your web applications. On this slide, we're diving into the topic of safe dynamic content rendering. Understanding the distinction between dynamic and static content is crucial for security. Dynamic content is generated on the fly and is particularly susceptible to injection attacks. This is because it often incorporates user input, which can be manipulated if not properly sanitized. In contrast, static content is fixed and does not change based on user interaction, thus posing less of a security risk. As developers, it's essential to be cautious about how we handle dynamic content to prevent vulnerabilities. Dynamic content handling in React involves using state and props to render user data safely. By leveraging React's built-in mechanisms, such as state and props, we can manage and display dynamic data without compromising security. This approach minimizes the risk of injection attacks, as React automatically handles many of the safety concerns for us. React's virtual DOM efficiently updates the components, ensuring that any data rendered dynamically conforms to the application's defined state and properties. This method provides a more secure and manageable way to handle dynamic content within your application. In this section, we focus on the risks associated with direct DOM manipulation using refs in React. Directly manipulating the DOM can bypass React's internal safety mechanisms, making your application vulnerable. For instance, consider this example. JavaScript this.myref.currentInnerHTML will x onroar. Here, setting the inner HTML using refs can introduce security risks such as XSS, cross-site scripting, attacks where malicious scripts can be executed. It is crucial to avoid such practices to maintain the safety and integrity of your application. Now, let's talk about dynamic parsing of React components. When rendering JSON data, it's essential to make sure that this data is sanitized before it's rendered. This is crucial for maintaining the security of your application. Unsanitized data can lead to vulnerabilities such as cross-site scripting, XSS attacks. As we handle JSON data, validating and sanitizing it prevents malicious scripts from being executed, ensuring safer rendering in your applications. In this slide, we will discuss a critical strategy for defending against code injection through JSON data, specifically focusing on server-side rendering (SSR). SSR involves executing your React code on the server side and then sending the fully rendered HTML to the client. This approach helps to convert dynamic content securely on the server, minimizing the risks associated with exposing raw JSON data directly to the client. By handling the rendering process server-side, we can ensure that our data is properly sanitized and validated before being presented in the browser, thus safeguarding against potential injection attacks. On this slide, we are focusing on two types of cross-site scripting attacks: stored XSS and reflected XSS. Stored XSS occurs when malicious scripts are permanently stored on the target server, often in a database, and then executed when a user loads a page with the compromised data. A classic example is user-generated profiles that fetch data from a database. If the data is not properly sanitized, the malicious script can execute, affecting anyone who views the profile. Reflected XSS, on the other hand, happens when malicious scripts are reflected off a web application to the victim's browser. This typically occurs via URL parameters. Attackers craft a URL containing malicious code, and if proper validation is lacking, the script is executed during rendering. This makes reflected XSS more immediate, as it doesn't rely on data storage, but rather on the real-time reflection of malicious input. Understanding these attack vectors helps in implementing the correct defenses, such as input validation, and contextual escaping. In this section, we're going to discuss the importance of sanitization of JSON data and how it can be effectively implemented using middleware for security. Here, you have an example of Express middleware. By integrating a middleware like this, you can sanitize JSON data before it's processed or rendered. The code snippet shows how you can use the body parser library in an Express application to sanitize incoming JSON data. By setting the sanitize option to true, you ensure that the application handles potentially unsafe data appropriately, thereby reducing the risk of injection attacks. This is a crucial step towards building a secure web application that can handle user-generated content safely. Let's see an example. JavaScript const express equals require express, const app equals express, app.use bodyparser.json, sanitize true. Here, the bodyparser.json, sanitize true middleware is configured to sanitize the JSON data, ensuring it is safe for use in your application. This approach provides a robust layer of security by preventing malformed or malicious JSON data from causing harm. Implementing such middleware not only simplifies the management of data integrity, but also significantly enhances the security of your applications. In summary, it's crucial to ensure that JSON data is sanitized before rendering. This serves as a primary defense against potential attacks, such as cross-site scripting, XSS. Additionally, always employ server-side protections to create a robust security layer. By consistently validating and sanitizing data on the server side, you significantly reduce the risk of malicious code execution. This dual approach of sanitizing JSON data and having strong server-side defenses creates a more secure environment for application development. In this concluding slide, we'll briefly go over some of the most important takeaways from this course. First, remember to prevent XSS vulnerabilities by using React's built-in security mechanisms. Secondly, always sanitize any dynamically rendered content to avoid potential injection attacks. On the server side, employing rendering techniques can provide an additional layer of protection. As we wrap up, I'd like to stress the importance of staying informed and regularly updating your knowledge on security best practices. Ongoing education is crucial in keeping your applications secure. For your next steps, consider diving deeper into secure coding practices and performing regular security audits on your React applications. Keeping your codebase up to date is key to maintaining a robust security posture. For those who want to delve deeper into the materials we've covered, I've included some invaluable references on this slide. First, the OWASP XSS Prevention Cheat Sheet is an excellent resource. It offers comprehensive guidelines on how to prevent cross-site scripting attacks, covering strategies that are crucial for maintaining secure applications. Next, the DOMPurify documentation will be immensely helpful. DOMPurify is a powerful library that sanitizes HTML and prevents XSS attacks. Reviewing its documentation will give you actionable insights into how to implement it effectively within your React projects. These resources should be a part of your continued learning as you strive to ensure the security of your applications. Make sure to explore them thoroughly to enhance your understanding and skills in secure coding practices. Ensure to attend all practical demonstrations, as understanding the application of these security measures in real-world React projects is crucial for mastery. By actively engaging in hands-on activities, you will gain a deeper comprehension of how to implement effective security practices. Happy learning!